So I want to just talk about what Burp does and session hijacking. So here I am at samsclass.info, and if you click on this padlock, you should be able to see the certificate. And here it tells you this certificate is issued by Cloudflare, and it's trusted. And if you look at the details, it's Cloudflare in San Francisco. And someplace is a list of the domains, and here you are, DNS name samsclass.info. So this certificate was issued to samsclass.info by Cloudflare, and it was trusted by Cloudflare here, and that's signed by Baltimore Cyber Trust Root, which is one of the known top-level certification authorities. So my browser trusts it and shows me the padlock and doesn't complain because it has a perfectly good certificate which is signed by Cloudflare, and Cloudflare's certificate is signed by Baltimore, and I trust Baltimore. So that's a proper certificate chain. But if I use the browser in Burp, it is breaking HTTPS. That is the whole point of Burp. So if I go to proxy, I turn off intercept, and I open the browser, and then in this browser, I go, let's go to history. If I go to samsclass.info here, then it warns me it's not secure. But I can see here, oh, that went to HTTP, so let's go to HTTPS. Let's go, it says secure. So let's try going, say, let me just go to, say, yahoo.com. I know that's always secure. I don't think I have an HTTP version. Yeah, let me put HTTPS, okay, / samsclass.info. Okay, that should have made a secure request. And there it is. Okay, so look at what happened here. Here in Burp, I can read the contents of an HTTPS request. That should not be possible. It should be encrypted with a key that's only on my server. If you look here for the certificate, it will tell you something is wrong. Here's the certificate. It's invalid. If you look at the certificate, it's issued by Portswigger. And Portswigger is not a trusted root CA. So it's a different certificate that it got with a different encryption key. This is what Burp does automatically. If you make an HTTPS request to Burp, Burp lies and sends you a fake certificate with a fake key, and Burp has the private key. So Burp is able to decrypt the traffic. It does it automatically. So when you see decrypted traffic here, the browser tried to use HTTPS, but a proper browser will warn you, like this one does, that something is wrong here because this encryption key I got is not signed by a certificate trust chain that leads to a known trusted root certificate authority. It's signed by some weird company called Portswigger, and it does not have a signature leading it to a higher authority. So I know I do not trust this key I'm using. I'm encrypting traffic, but I do not know that the key I'm using really belongs to this website, samsclass.info. Now, my server has no way to know that anything is wrong because Burp will now make a real HTTPS connection to my server and send it with the right key. So the server will perceive that somebody is connecting correctly, but my client will warn me that something is not right by popping up not secure here. It doesn't mean the traffic is moving without encryption, but it is being sent with a fake key. So there is a third party somewhere that has chosen to send you a fake key, and that means there is somebody that can spy on you. Now, SSL strip is even worse. SSL strip would just deliver it over HTTP, so it's unencrypted entirely, and anybody around you could see it. Anyway, that's real important, and that's what you're seeing when you have an Android app. If your Android app allows you to connect through Burp, and you can see it here, then your Android app is not detecting this flaw, that the certificate chain is broken. It really ought to just pop up a warning saying, untrusted root certificate or something. And if it doesn't, then the developer has failed to correctly implement HTTPS. They have not done the check that they should have done, so they haven't properly followed the recommended procedure. And that happens pretty often. So that's what I wanted to show you. I'll stop this one.